So in this video, we're going to be talking about the image processing step, one of the steps in image processing that includes blurring and smoothing. So image blurring or image smoothing is basically the convolution of image with a low pass filter, and it's mainly used for reducing noise in the image. The noise is removed while the main image is kept unharmed. So that is happening because of the low pass filter, which keeps the image material unharmed and reduces the noise content to lower levels. So image filtering that we're talking about, it is basically the process of modifying an image by either changing its shades or colors or pixels, and basically it involves either smoothing or enhancing of the detected edges. So OpenCV has a function called cv.filter2d, which can convolve this kernel with an image, which will produce the desired results. So we basically have 4 methods of blurring or smoothing in OpenCV. These involves averaging, then there is then there is Gaussian blurring, and the third one is median blurring, and the fourth one is bilateral filtering. So we'll be talking about these 4 functions one by one, starting from averaging.
Now let's talk about one of the blurring or smoothing methods, which is averaging. When we apply averaging on our image, we convolve our image with a normalized box filter, that is a kernel which looks something like in the picture shown here. K width and K height are the width and height of kernel. So suppose your kernel width and height is 3, then you will divide the unit matrix by 3 multiplied by 3, which is 9, to get a normalized box filter. So we use this filter to average all the pixels and place it in the central element. We can implement averaging using OpenCV functions like cv.blur or cv.boxFilter. Here we will see how cv.blur works for averaging an image. The syntax is shown here. The important arguments taken are source image, kernel size, which is a tuple with height and width of kernel, and other optional arguments are destination image, which is the output image. Anchor is the anchor point where the default value is -1, which is at the kernel center, and border type. It returns a blurred image with same size and type as source image. Now let's see this work in a Colab notebook. First we import the requirements OpenCV and cv2_imshow, and we use cv2_imshow because imshow method from OpenCV does not work on Colab, so this is a great workaround for it. Then we read the image using imread method. This is how our example looks like. Let's set the kernel size to 8,8 and then apply cv.blur method. This is how our final output looks like. Now let's try increasing our kernel size and see how output looks like. You can observe our output looks more blurred than before. So you have seen how averaging works. Now let's talk about another method of blurring, that is Gaussian blurring. For Gaussian blurring, we use Gaussian kernel instead of a box filter. Gaussian blurring works very well to reduce noise in our image. It is also used to smoothen small, sharp edges in image without doing too much blurring. We use cv.GaussianBlur method to implement Gaussian blurring in our image. Methods takes arguments such as source image, K size, which is kernel size with height and width of kernel, and other optional arguments which are destination, sigma x and sigma y, which is standard deviation in x and y axis respectively. Let's try to implement this method on our previous example. Here we have the kernel width and height as 9 and sigma x is 0. Now let's run this. You can see how edges are getting smooth in our example.
So now let's talk about the third type of filtering method, that is median blurring. The median blurring is same as the above two methods we have used. It is very fruitful against the images that contains the noises like salt and pepper ones. We know that there are many kinds of noises, so one of that is the salt and the pepper noises that median blurring removes. So its central element is always replaced by some pixels that the users gives to the commands. So we have its function cv.median blur. So we have inputted this image, the first one that we have inputted it, and the result that we have got after median blurring is this one. So now let's talk about its code that we have run on the collab. So its code is this. I have saved the main image that I have shown in the GitHub. That the first one, I have saved it from OpenCV.jpg. After giving the parameters and all, uh, and running this code, we have got this as our output. So now let's talk about the last type of filtering method, that is bilateral filtering. So it is all the same as other filters, but is it's this operations takes a bit more time. It is come it as compared to others, it is bit slower process. So at this filters, it's what it does, it sharpens, it do not smoothens the edges, but it keeps the image as sharp as it is. But the other filters that we have used above is just smoothens the edges as well. By smoothing the image, it also smoothens the edges, but this filter do not do this. So this is the main advantage over any other filter, but only disadvantage is that it is bit slower as compared to others. So we have used this image, the main image that we have used is this, and after running its code and all, we are the final output that we've got is this. So now let's move to the code that we have used for it. So the coding that we have used for bilateral filtering is this. We have, as we know, we have as we know that I have saved the main image from OpenCV.jpg in my system. So we have coded some parameters that we want to change in that particular image. So after running this code, we have got the image as the output as this. So yeah, that's all from our side. Thank you.